Alright guys, tonight we're going to be rebuilding an FMS p-51 that's been previously crashed on a couple occasions. This aircraft was given to me by one Duane Honey Badger. I know it was owned by another pilot, I can't remember who. They both had issues with it flying. What we're looking at here is the first image I took of it, pretty much the way I received it. A little bent up in the... This is just another view showing the damage to the front end, the off-center of the motor mount. Just some of the overall damage before I really started tearing into it. You can see it's pretty out of line. The first thing I had to do was straighten the motor shaft some with the pliers, gently and carefully, just enough to get the prop nut off and start the disassembly process. It was pretty easily done with just a couple pair of needle nose pliers and a little patience. What we're looking at in this image is the motor coming out of the motor mount. There's two screws at 3 and 9 o'clock on most of your FMS models that can be accessed from two holes on either side of the nose of the airplane to remove the motor without actually taking the mount off the firewall. You can see I've already removed the prop and the cowl getting to this point. Here we can see I've got it all torn apart. The motor mount's out, the motor's out. I've also removed the EFC and all the electronics from the front of the aircraft for the next step in the straightening process of this aircraft. I decided to go with the hot water method to straighten the foam of this aircraft. Often if you have a model that's bent or wrinkled, adding it, pouring some hot water, soaking it in hot water, will straighten the foam. I tried first at 150 degrees, as you can see me measuring taking my temperature of the water with the thermometer here. I found that wasn't quite hot enough, and I did a second soak at 170 degrees. This is image of the first soak at about 150 degrees in the water. I had to find a pot big enough to really soak this nose of the airplane. I needed about 6 or 7 inches of water depth to really get it in as deep as I needed to take all the wrinkles out. So I pulled my old pressure cooker out and I added about 2 gallons of water and heated it up. And at 150 degrees it wasn't quite hot enough to really do what I needed to do. This is looking at the second soak. I took the water up to about 170 degrees. You'd see some bubbles starting to form. The water's not boiling yet. I held it in there for about 30 seconds, making sure to fill all the cavities with hot water and move it around, keep the hot water hot inside the aircraft. 170 degrees seemed to do real well at about 30 seconds. I pulled it out and it really was straightened right out. So that really completed what I needed to do there. You can still see a few wrinkles in the paint, but the foam itself and the nose itself really straightened out. The motor mount tightened back up as the beads in the foam swelled up, and overall I was real happy with the result. This is just another view of the other side after the soak. Really didn't do anything to the paint. I thought maybe it might blister the paint, but it did not. So again, real happy with the results I got out of this. And again, the water temperature is about 170, 175 degrees. And a big thing, I guess, is don't push the foam against the bottom of the pan, or you could do some damage because the heat of the bottom of the pan will actually scorch the foam. What you're looking at here is me taking a look at the shaft after I straightened it with the pliers before I took it out in the garage. Once I took it out in the garage, I didn't have the lighting to take photographs. But basically the process is I have a couple flat plates I can put in my vise to keep it from messing up the shaft, and putting the shaft in and just squeezing it straight gently. If I have some other little bends, I might take the needle nose pliers, heat the shaft up and give it a little attention with the pliers. Something I do to any shaft after I bend it and get any kinks out of it, unless it's really bad, which I guess this shaft was pretty bad, but I will actually take out my torch, pull the shaft out, heat the whole thing red, glowing hot, and drop it in water. Then I'll reheat it a second time to temper it to keep it from being too brittle, but that relieves any of the stresses in the metal from the bending process and puts it back in to like new condition. I think what we're looking at here is pretty self-explanatory, just rebalancing the prop. Once the shaft is bent, just to make sure I've got everything squared away, I want to double check every last piece of it to make sure everything is perfectly balanced. If I know everything is balanced and I'm having vibration, I know my shaft isn't quite still right. So in this picture, I'm going ahead and rebalancing the prop, cleaning up the little dinged ends. Now we have the prop balanced, it's time to put the motor back in. I did take and actually glue, what you can see in here if you look carefully, is I've actually put glue all the way around the mount. I prefer on motor mounts, anything I might experience vibration, to use the glue that comes with a lot of these kits. It's got good adhesive properties, but it also takes shock and vibration well without breaking up like CA will. What we're seeing here is after I got the motor mount back in, waiting for the glue to dry, I also decided to balance the spinner. It's a good idea to anything that rotates on that shaft can cause vibration if it's not in balance. So never be afraid to check spinner plates and spinner cones. It's easy to do. Throw it on, make a witness mark, either the inside of the cone or somewhere it's not going to be seen later on the model, and just use that as a reference. Usually I'll put it on the balancer, and the heavy side is where I'll actually make my mark at. In this image you can see where on the heavy side I've actually taken my Dremel tool and ground just a little bit off the back of the spinner. You don't want to take too much, just a little bit off each one if you can. Because this is such a small spinner, I couldn't quite do it the way I really wanted to. So I did what I could. This is what I ended up with. And from here I went and put it back on the balancing shaft. What we're looking at here is, of course, the base plate of the shaft. My witness mark is now 90 degrees off the side. I've turned it, rotated it, and it stopped in multiple positions. So now I know my spinner base is also good and true and balanced. Should I have any vibrations after this point, I know I still have an issue with my motor then. What we're looking at here, of course, this is going to be my first run up here. You can hear it running up nice and clean and free. Watching the model through the power range changes, you can see no vibration. With my hand on the tail, I can't feel any vibration, so I think I'm all set. What I'm looking at here is the foam hinges are starting to give way on this model, so I have to deal with that. I'm going to be just trying a little rubber cement method versus actually pulling it apart and putting hinges in it yet. Being it's just starting, I'm hoping I can stop it before I have to tear it all apart and put pin hinges in it later. Which, if I have to, it's no big deal. I can do that, and I can do a video later. Well, we already saw the left wing has it. The right wing has the same problem as well. So, the next couple images you're going to see is what I'm going to do about that. Okay, what I'm doing in this image is I've actually got my bottle of rubber cement out. I've taken a bamboo skewer at the sharpened end. I've got some rubber cement on the end. I'm just working it in that crack where the parts have actually separated. Carefully working, making sure I have all the surfaces covered inside there. The rubber cement will also give me the flexibility I need in a hinge area. Alright, what we see here is I've got my blob of glue I dump in, and I do this top and bottom in both grooves. I will go ahead and lay the glue in this fashion, and then I will take a bamboo skewer, the round end this time, and actually lay it in and just put a very thin, smooth layer all the way down the surface. It helps, the rubber cement is flexible. It helps rebuild that broken hinge system, and again, if it doesn't work, later on, I'll always go get some of my Robart, I forget the actual name, I call them pin hinges. And I will go ahead and put those in if this doesn't seem to work. Well, here it is, guys. All pretty much done sitting, taking the last step on my balancing stand here. I've robbed the landing gear and nose cone off my P-40. Uh, they apparently fit well, so tossed them onto the just for a final test run there. Put them on the Mustang. Of course, I didn't get the manual with this aircraft, being it's third hand now. So I had to go online to find the CG, and I found out something interesting. I guess the manual, the CG calls for 45 millimeter from the front of the wing, and everything I've read that's not quite right. A few other gentlemen have found that 65 millimeters from the leading edge of the wing at the fuselage works a lot better than the called for 45 millimeters at the front of the wing. I'm wondering if that isn't because the contour of the wing, if they're actually measuring from the actual wing instead of the wing fillet. But anyway, if you're measuring from the fuselage, from what I've understood, it's 65 millimeters. So we're going to take that out, give that a shot, and see what happens. For everybody involved in this project, Duane, and again, whoever gave this aircraft to Duane, I can't remember who it was. Thanks a lot, guys. I enjoyed this. I hope you guys find this video informative. And if you like it, comment. I'll keep doing more. Send me requests, and we'll see what I can do for you. Thanks again.